I said a second ago, how do we know that the universe even had a beginning? Well, it obviously did, or we wouldn't waste time developing a scientific model to describe it. But how did we arrive here? How do we know there was a beginning for sure? And why are we so confident that the Big Bang model describes this beginning? Well, let's have a bit of scientific history for a moment. It's the early 1900s. Most people have adopted the assumption that the universe is fixed in size and unchanging. However, new ideas came to light between 1915 and 1916, when Albert Einstein published his theory of general relativity. This theory allowed for the expansion and contraction of space, and quickly sparked some big ideas amongst the scientific community, with various astronomers, mathematicians, and cosmologists applying Einstein's theory to the entire universe, and concluding that the universe could be expanding. This gave rise to the idea that if the universe is expanding, then if we simply stop time and reverse the process, then we can simply work out where the universe came from, just like tracing back footprints in the snow, or rewinding a VHS, if you know what they are. These ideas introduced exciting possibilities for the understanding of the universe, but they were merely thoughts, and there was no observational evidence to suggest this was really the case. Around the same time as these new ideas began to be postulated, astronomers were noticing that there were more galaxies moving away from us than towards us by observing the spectrum of light that they gathered. Okay, so behind me is a picture of our sun. As you can see, it's basically just a massive ball of plasma. In fact, a million Earths would fit inside there. Now, you may not have known that the sun was made of plasma, and that plasma is one of the four fundamental states of matter and the most abundant in the universe, and also the same science that makes your plasma TV work. Well, what you will know is that the sun emits light. This light we call white light. Now, at some point in our lives, we've all seen a rainbow, and we've seen the different colours and marvelled at how pretty it looks. But what you have seen is a spectrum of light appearing in the sky. This is caused by the reflection of light inside water droplets inside the Earth's atmosphere. This can also be done in a laboratory using a prism, just like you probably did at school. However, what you may not realise is that white light is not just an array of colours from blue to red, it actually has dark bands through it at very specific locations. These dark lines are the fingerprints of the chemical elements. Now, the elements are made up from an atomic nucleus with electrons orbiting around it. We'll go into more detail regarding the elements later, but for now all we need to know is that every element has a different nucleus with a different arrangement of electrons. As light shines through an element, as each element contains a different arrangement of electrons, then different elements, say helium or oxygen, will absorb different colours of light that directly relate to the arrangement of the electrons in that particular element. The element will absorb and emit light of the same colour in the spectrum, and it is therefore possible to see what elements objects like stars and galaxies are made from. What the astronomers noticed as they examined the light they gathered from the distant galaxies is that the spectrum was identical to that on Earth, as all the elements are the same across the universe. However, the dark bands in the light from the distant galaxies were shifted and not in the same place in the spectrum. They quickly realised that the reason for this is that the universe is expanding, as claimed by the scientists at the time, and here's why. As the light travels from the distant galaxy to us, it takes time to do so. As light isn't instantaneous, it has a speed limit, a game which we will look at in a short while. As it travels across space from the distant galaxy to us, the wavelength of that light, which is what gives the light its colour, gets stretched by the expanding space. As the wavelength gets stretched, it directly affects the colour of the light, so it will shift within the spectrum. Now, red light has a bigger wavelength than blue light, so as the universe expands, it stretches the space that the light is travelling through, thus stretching the wavelength of that light, making it bigger and therefore moving towards the red end of the spectrum. This also works the other way around. If an object's light is moving towards the blue end of the spectrum, then that object is approaching us and not moving away from us. These are referred to as redshift and blueshift, and can be thought of in the same way as if the sound of a fixed volume gets closer to you, it sounds louder, than if it gets further away from you, it sounds quieter. The astronomers noticed that there were significantly more galaxies whose spectrum was redshifted than those whose spectrum was blueshifted, providing observational evidence for the first time that the universe is expanding.